Today's lesson is on 4.3. We're going to split this into 2 days. So today is just the introduction, 4.3a. It's going to introduce point slope form. This is the last of the linear forms of equations. So to review, we've learned standard form, aka useless form, right? Good for x and y intercepts, nothing else. It doesn't give us anything. We just finished graphing and writing equations in slope-intercept form. We will still be referencing those, but today is the last form, not as popular as the other two. This is more of a transitional form. This helps us get into the other forms, giving clues. Okay, so it's another form of a linear equation. It's just another name of a linear equation. So I kind of color coordinated things here. The equation itself looks a little funky. It has a y minus a y equals m times x minus x. I know there's a sub ones in this for the ordered pair. I tried to coordinate it. There's two different colors there. If you're two different y's and two different x's. So in trying to color coordinate that, I'm trying to point out that this y value is from the ordered pair. It's an actual number. This x sub 1 is from the ordered pair they give you. That's called the point. And so this is point slope form. They're going to give you a point, any point, and then they're going to give you slope, which is m again. So we know m is slope. But the other x and y just stay x and y. So if you look at the other forms, you know, when we have this standard form, the a value, the b value, and the c value are all numbers. And then an x and y stay in the equation because that represents every ordered pair on that line. It's a spot where we can plug in values. Same thing with slope-intercept form. Y equals 2x minus 1. The slope became a number. The b value, y-intercept became a number. But the x and the y, there's your x and y that stay in the equation. So what this thing will look like, I'll just show you one of them. It might look like this, y minus 3 equals 2 times x plus 1. And so that would be point slope form, a little bit different than what you're used to. Here's the ordered pair, there's a y coordinate, there's an x coordinate of your ordered pair, and there's your slope. But once again, this x and this y kind of stay as just x and y in the equation. So we can write this given any ordered pair. I believe they were showing. So the idea is you can use any ordered pair. So if this is the ordered pair you want to use, or maybe this is the ordered pair you want to use, it doesn't have to be. It can be the y-intercept, but it doesn't have to be the y-intercept. So this is a little bit nicer in the fact that you can use any point, and we can graph from any point when it's written in this form. Okay, so we're just going to kind of practice writing the equations, given the point, given the slope, putting it in this form, and then also rearranging numbers into this form, that sort of thing, or from this form. So the first ones here, write the equation in point slope form of the line that passes through the given point with the slope provided. So let's just put this on here again, y minus y equals m times x minus x. This is where it gets a little funky. Do you see those negatives? The equation itself has a minus in it. So when you plug in negative numbers, just like the slope formula, it turns into a positive. When you plug in positive numbers, you're actually going to subtract them. So they're going to look opposite of what they really are. So this is going to be my x value. This is going to be my y value. So when I plug them in, I am replacing this spot right here with the x and the y. And then the -6 slope will go in for the m. So for number 1, and then it asks us to graph y. The y value is 5, so minus 5. The minus is because of the form. The 5 is positive, so it stays y minus 5. It still looks like a -5, even though it's a positive 5. Equals -6 slope times the parentheses x. When I say minus a -2, it turns it to +2, just like the slope formula. So that is the point slope form of that equation. And when we go to graph it, what's nice about point slope form is you can recognize that this is the ordered pair if they hadn't given us the ordered pair, if I can see the ordered pair here. But notice this +2 really represents a -2. And this -5 really represents a +5. That is the hardest part, is you got to think like opposite. So my ordered pair, -2, 5. I go to the left 2, up 5, and that becomes my beginning point. We're not going to begin necessarily on the y-axis anymore. And then from there, I'm going to count my slope. I'm going to go down 6 and over 1 to the right. And then if I have more room extended down here, down 6 again. 1 to the right. My line should be falling. It should be very steep because the slope of 6 is very steep. And there's your line. So we're still using slope to graph the line. It's just where our beginning point was not the y-intercept. It was up here, just some random point. Okay, let's try it again. So here they're giving us a +4 and a +3. So this is my x, this is my y. I'm going to use this equation again, and my slope is -1/2. So to put that into point slope form, y minus 3 equals -1/2 times the quantity x minus 4. In the actual equation, they both look negative because in the actual ordered pair, they're both positive. The only way that those negatives would turn into positives is if we put in a negative number. So let's go ahead and graph this. We're going to start at 4, 3, because that was the point they gave us. So why we call this point slope form. They give us any random point, and then the slope of -1/2. I'm going to go down 1, 2 to the right. I ran out of room, so I'm going to go up 1, change the direction up, then change left. 2, up 1, 2 to the left, and then connect and extend. Okay, you don't have to do those loop-de-loos. I just think they help, where you can, not touch the pencil to the paper and actually count, but you're counting spaces when you count spaces for slope. All right, so that's graphing and rewriting them, given the point and the slope, just kind of plugging them in. If we go to the next section, we're going to work backwards. They're giving us the line, and then we need to put it in point slope form. Now, this is where there's tons of different points we can use. So we look for a good point. And what I mean by that, like this would not be a good point, okay, because it's not at a crisscross. So you're looking for somewhere on here where the graph crosses. So I could use this ordered pair. I could use the y-axis, the y-intercept. I could use this ordered pair. So I'm going to go ahead and just use this one random point up here. I'm going to choose this one, but this is where this form kind of can get a little crazy. Every single one of you could pick a different point and we'd all be right. So point slope form is very specific to the point that you picked. So if this is my ordered pair that I'm picking, that is +3, 1, 2, 3, 4. That's +3, +4. And then I got to count my slope. So I'm just going to go from here up 2. I went up 2, and then I went 1, 2, 3 to the right. So here's my point, and then my slope is a +2/3. So my equation, when I put that all together, y minus 4 equals +2/3 x minus 3. Now I know the y value comes first, so you have to go to the 4 first, right? You got to go to the y. Then we plug in the x. It's a little backwards, but slow down, and then the more you do it, the easier it gets. Same thing here. I've got just scanning the line. I've got this ordered pair. I kind of need 2 ordered pairs to count slope. So I'm just kind of looking for 2 spots that are nice. Looks like my x and my intercepts are nice here. And so when I do this, I'm going to go ahead and use the x-intercept as my point, my ordered pair, 1, 2, 3, 4, 5. So that would be 5, 0. Somebody else might use 0, 1. So our answers would be different, but let's all use 5, 0 just to be consistent. This is my x, this is my y. And then to count my slope, the line is falling to the right. I went down 1, and then 1, 2, 3, 4, 5 to the right. So my slope is -1/5. So using that information, I get y minus 0 equals -1/5 times the quantity x minus 5. Okay, and then one more time here. Vertical lines, we're going to spend a whole day on vertical and horizontal lines. These are kind of a pain in the butt. We can do the best we can, other than we don't have a slope to plug in. When we rise only, right, we're rising or falling, it doesn't matter which way we decide to go here. If I rise 4 or I fall 4, it really doesn't matter, or 5 or 6, but I never run. And so if I'm not running, I have a 0 in the denominator, my slope is undefined. What we have to learn as Algebra 1 students is that that's a clue, that's a vertical line. If I don't have slope to plug in, then I can't write the point slope form because it doesn't have slope to plug in. How do you plug in a number if it doesn't exist? So now we just have to, I usually make a table of values and I ask myself, okay, well, what are these ordered pairs? So if you start listing the ordered pairs, you're going to see a pattern form. These ordered pairs are -2, 0, -2, 1, -2, 3, -2, 5 million, whatever. Right? But the idea is, in order to be on this line, we went to the left and then we went up and down. This right here writes your equation. All of my x values are equal to -2. This is a vertical line. Vertical lines are x equals something, one variable, one direction, x equals -2. So kind of just throwing a little stinker in there to kind of teach you that lesson. All right, and then the other part of this lesson is just being able to, it's already in point slope form. Let's identify it, work backwards and find the point, and then we're going to put it into standard form. We're going to actually transform this into standard form. So remember, standard form is this useless form with all the rules. That order, A has to be positive, they all have to be whole numbers, all that fun stuff. Okay, so let's go ahead and identify what we need to identify. Here, we're identifying that my point, the point is 3, 5, both positive because they both say minus, so that means I didn't plug in a negative, and my slope is 2/3. So just working backwards to pull the information from the equation. And then let's go ahead and transform this. So to transform here, it involves distributing the slope through. So y minus 5 equals 2/3 x. When I multiply 2/3 times the -3, I get -2. You can use your calculator there. All right, so I'm getting closer. I got to get into this ax plus by equals c. I'm going to, I know they have to be whole numbers, so I'm going to take care of that 3, that thirds. I'm going to get rid of that first. I'm going to multiply everybody by 3. You can do this last. It doesn't have to be first, but it has to be done. To get rid of that thirds. So that's going to make a 3y minus 15 equals 2x minus 6. Everything got 3 times bigger. And now I can rearrange. So I need to bring this -15 over here. I'm going to add 15 to both sides. And at the same time, I'm going to bring this 2x over here. I'm going to subtract 2x and put it over here. You could do that in 2 different steps. I just would rather just do it all in one. So I'm flip-flopping everything. I'm bringing the x over with the 3y. It's negative. -2x goes out in front, plus 3y. The 15s disappear. The 2x's disappear. And a -6 plus 15 is 9. And so now the only thing I have to change now, they're all whole numbers. They're in the right order. But A has to be positive, so I switch the sign of everybody. So kind of a pain in the butt. Standard form is always a pain in the butt. Okay, and then one more time here, I think we're going to do slope-intercept form. So this time we're going to, our goal is to change this into slope-intercept form. So you just got to read the directions and make sure you're doing the right form, what they want it to be written in. But that's the whole purpose of point slope form, is it's a transitional equation. We're going to use it quite a bit in the next section when we do the second half of this. They're going to give us clues of lines and we're going to write the equation. So same concept. My point that is here, this is my x value, but notice it turned into a positive. This is my y value. This one also turned into a positive. So that means my ordered pair that they're plugging in the point is a -3, -7. And my slope is also negative, which is -5. So I identified the slope and the point. And now we're going to put it into slope-intercept form. The process is the same. We start off with the distributed property. We got to get rid of those parentheses. So y plus 7 equals -5x minus 15. But now, instead of putting it into slope-intercept form, I'm looking for this form. So I want to leave this here. I want to leave this here, but I want to move that 7 over. So I'm going to subtract the 7 over. Just to get y equals, got to get y by itself, -5x. And I put it underneath the 15 because they are alike. I can put -7 and -15 together and get -22. So you can transform point slope form into any other form. Okay, it's our transitional form of the equation. All right, so your lesson summary, just identify, okay, tell me the slope and the point, just like we did in the last examples, and then write a point slope form of this linear equation. You can use any one of those red dots that I gave you. So there's 4 different equations that you guys could give. Good luck.